Hey guys, this is Chapter 1, an Introduction to Business Statistics. This is going to be the lecture for Chapter 1, so it'll be PowerPoint and the exercise sheet that we'll look into today. First, I wanted to cover some things that I forgot to mention in the intro, so kind of a continuation of that. I am a dad, predominantly a stay-at-home dad, so from time to time you might hear my kids in the background either yelling or crying or playing, or you might hear the dog barking in the background. I am recording these from home in my office. And yeah, that's that. So a bit of real life. I think on the intro you heard my almost 2-year-old crying, waking up from a nap. So yeah, it's really tough to edit out background noise. So I'm just gonna kind of leave it in there. So kind of is what it is. So little glimpse into the life here. So, yeah, next thing I wanted to mention that I didn't say in the intro is feel free to come by the office and visit me if you'd like. A lot of times in these online courses, it's really impersonal. Some people really, really like that and never want to see a face and never want to, meet anybody and whatnot. But some people want that interaction, just like to know who they're dealing with, that sort of thing. So I'm at the university on Tuesdays and Thursdays predominantly, like most of the day, because I teach on Tuesdays and Thursdays the other section. And yeah, so feel free to stop by the office or make an appointment with me, just to, I guess, to make sure that I'm there. I don't know how many of you are close by to campus or not. So yeah, that's that. Another thing I wanted to mention is this course is going to be fairly fast paced because we have a lot to cover. Back in the day, this course was 2 different courses. It was called QBA 1 and QBA 2, Quantitative Business Analysis. And they kind of squished those 2 courses into this one course and then chopped off a little bit here and there. So yeah, so there is a lot to cover, but you get a lot of good information. So it's good that it's in one course. Yeah, so the way that you're going to want to go about this class and these lectures, every Tuesday, this is the plan as of now, right now. Every Tuesday, I'm going to post a YouTube link for that week's content. So this week it's going to be chapters 1 and 2. Normally every week it's going to be just one chapter. I'm just going to follow whatever we have homework on. So this first homework is chapters 1 and 2. So I'm going to post chapters 1 and 2, the lesson content. With that, so I'll post a link to it on Springboard. And then in Springboard as well, I'll post the PowerPoint slides. And then I'll also post the exercises and review Word document. So the exercises portion of that Word document is going to be something that you can actually use to follow along during these lessons. I'm going to refer to it. I'm going to work out problems in it. And so you can use that to follow along and kind of do, the classroom examples and whatnot. The review portion is going to be after that. That's going to be something that is done supplementary to the lesson. I'm also going to be putting out a video for that. And then you'll be able to follow along for that video. So if you've got the concept down, you don't feel like doing the review, fine. That's your choice. But there's going to be some of it where we're actually looking at the PowerPoint slides and coming up with answers based upon that and based upon what we've learned, or based upon what we're learning. And then the review is going to be based upon what we have learned. And then you guys will have, your homeworks separate of these lectures and whatnot. And those will be due predominantly, or I guess mostly, like right around a week after I release the content. Okay, a lot of these date things, like you'll see on the syllabus, like those aren't set in stone. We're gonna play with that throughout the semester. I've got to see how things are going, how well I'm presenting the content, how well you guys are absorbing it, all that stuff. Like, yeah, so that's that. And yeah, I'm gonna, with the exception of a long introduction for this video, I'm gonna try to keep these videos as concise as possible. One thing that you'll find out is this isn't going to be a 75-minute video like a normal classroom lecture would be. This is going to be more of, I'm hoping, a 20-25 minute video, because you're not going to have that back and forth classroom experience that you would of, student raising his hand and asking a question, then me answering it, and then there being a level of confusion, and then more back and forth, and this and that, because that's that's what happens in class. This is going to be, A to B, me giving you the content. So the questions that you need to ask them in the discussion tab so that everybody can see them, and so that when I answer them or when a peer answers them, everybody can see those answers, discuss those answers, and we can all learn together. So I think that is all I have to cover prior to starting, so let's get started. So chapter 1 outline, we have data sources, populations and samples, case studies that illustrate sampling and statistical inference. We're going to look at one case study, and then there's going to be 2 that are optional for you. And then NOIR, which is nominative or nominal, ordinal, interval, and ratio. Looks like we have them listed there in the other order, which is fine. Those are scales of measurement. So we'll start out with data, which is facts and figures for which conclusions can be drawn. So that's like an unbelievably broad statement. And really that can be defined as anything that is measurable in which we can draw a conclusion from. So that's data. So most of you know what data is. You've been using it all your lives or all your school lives and whatnot. And then there's data set, and that's just the fact, or that would just be data is collected. So that could be on a spreadsheet, that could be on a list, that could be on paper, any way. But as long as the data is collected in some organized fashion, then that constitutes a data set. Elements of the data, that refers to like the specific thing that is being measured. Like say you get called for like a political survey. They ask you a bunch of questions, and you give answers to a bunch of questions. The element in that is going to be you, the person who's being asked the questions. So there's eventually going to be variables, which would be the answers to your questions, and then there's you, the element. So there would be, realistically, they will call hundreds of people, and each person that they call is the element of the study, and the variables are the answers that they give to the particular questions that they ask. So variable, any characteristic of an element. So a variable might be the answer that you give. A variable might be your hair color, your ethnicity, your age, anything like that. Those can be variables. So it can be an opinion, it can be a quality of you, anything like that. So that's a variable. Also, variable can be, like, I guess another example would be what we would commonly refer to as like sports statistics. Like you have a baseball player, he has a batting average. Batting average is a variable. RBIs, variable. Walks, on base percentage, those are all variables. Measurement, a way to assign a value of a variable to the element. Okay, so a measurement is just going to be how do we assign value to that variable of the element. So if we're referring to like the speed of a runner, the way that we assign value is, like, say it's Usain Bolt and he's running the 100, like he's going to be running that in seconds or seconds to the 100th. That would be the measurement. Speed of a car, miles per hour. If you went to the doctor and they asked you to rate your pain, what do you rate your pain? A scale from 1 to 10. Oh, it's an 8. Okay, that's a variable. Albeit a very subjective variable, that's a variable. If you take a survey and you get asked, were you extremely satisfied, somewhat satisfied, neutral, somewhat dissatisfied, extremely dissatisfied, or NA, that would also be like that extremely satisfied to extremely dissatisfied. That's your measurement. That's your scale of measurement. And that brings us to quantitative versus qualitative. Quantitative just means it has to do with numbers. So there's going to be some way for us to quantify it. Qualitative, it just means it has to do with qualities, so not numbers. And in the examples that I just presented, like the speed of a runner, that's obviously going to be quantitative. Speed of a car, quantitative. Pain at the doctor, I mean, that's quantitative, I think, but that's kind of debatable just because, yeah, we'll say it's quantitative. Yeah, let's go with that. But then, for example, like the survey where you're asked extremely satisfied, somewhat satisfied, that whole thing, that's definitely qualitative because there's not a number associated with it. Okay, so we'll go ahead and we'll refer to Chapter 1 worksheet. And we are going to do number 1. So we're just going to identify the different pieces here. Okay, so identify data. Well, this is all data, right? So that's all data. And then where's the data set? The data set just refers to the great writing, the organization of the data. Like the data is in a list. It's categorized well, so that's the data set. Elements. What are the elements? We just talked about, like, if you got called for a survey, you would be the element. So this is a data set describing 5 home sales. So the homes are the elements. So elements. Variables. The variables are just going to be the different characteristics of it. So model design is a variable, lot type, list price, and selling price. Those are variables. So we've got data, data set, element, variables, measurements. So measurements for this are going to be diamond and ruby, and that would be qualitative. Lake, treed, and that would be also qualitative. List price, that's definitely quantitative. And selling price, also quantitative, because they have to do with dollar values. Cool? Cool. I'll get back to the PowerPoint. Next thing, we're going to look at different ways to categorize data. We have cross-sectional and time series. And cross-sectional just refers to data taken at any singular point. So, yeah, any data taken at any singular point, and then time series is data that's taken over the course of different points. And we'll look at some examples here that should make that a little bit more clear. So this is an example of cross-sectional, the 10 most popular car colors in the world for 2012. Okay, so don't think of 2012 as a long period of time or a period of 365 days or a certain amount of time. We're standing on 2012 and saying that's one point. And then this data that's in there is within 1 point. So we just have a bunch of qualitative data, colors of cars in that 1 point that is 2012. So we call that cross-sectional data. If we had data that was 2012, 2013, 2014, all the way on down the line to wherever, then that would become time series data. But right here, this is cross-sectional data because we're standing on 1 point and we have data for that 1 point. And then time series data. We can look here, 1999 all the way to 2009, the average basic cable rates in the US. So these are dollar values, so this is quantitative data, and it's taken over different periods of time. So we know that that is then going to be time series data. Then we'll just briefly touch on data sources. And the existing data sources are just essentially, you know, the internet, library, U.S. government, and data collection agencies. Examples of these would be census.gov or the Bureau of Labor Statistics, which I believe is BLS.gov. So those would be existing sources, meaning you could just go there and pull down data and then run run statistics on it or come to conclusions or determine if it's qualitative or quantitative. Just the tools that you have at this point. And then experimental and observational data. And we note that there's a response variable, that's the variable of interest, and then the other factors, which would be the other variables that aren't the response variable. So just the things that might contribute to the response variable. And experimental data are, like we mentioned, surveys, studies that are done by consulting firms, that sort of thing. That's going to be experimental data. And then this is how we would look at initiating a study. This is not something that we're going to do too much of in this course, but this is something that we just want to touch on so that you kind of understand it, because it might be something that you use just in the future. But more than likely, for like our case, we're going to be given a data set and then have to use the tools that we required at the time to analyze that data set and produce something. So first we define the variable of interest. If we're initiating a study, we call that the response variable. Next, we define other variables that may be related to the variable of interest and will be measured, called independent variables. Now this is where we determine whether something is experimental or observational. If we manipulate the independent variables, we have an experimental study. Okay. If we do not manipulate, or we're unable to, then the study is observational. I'll read a quick excerpt that'll kind of give you an example. So here's an example of an experimental study. This is also in your book on page 6. So if you want to read it on your own, that's fine. A pharmaceutical company might wish to determine the most appropriate daily dose of a cholesterol-lowering drug for patients having cholesterol levels that are too high. The company can perform an experiment in which one sample of patients receives a placebo, a second sample receives some low dose, a third a higher dose, and so forth. This is an example because the company controls the amount of drug each group receives. The optimal daily dose can be determined by analyzing the patient's responses to the different dosage levels given. So that's experimental, clearly, because they're manipulating one of the independent variables. So that's why that's experimental. Then there's an example for observational, which is in studies of diet and cholesterol, patients' diets are under the analyst's control. Patients are often unwilling or unable to follow prescribed diets. Doctors might simply ask patients what they eat and then look for associations between the factor diet and the response variable cholesterol level. So regardless of the reason that they can't manipulate one of the independent variables, they just look at the information that they have and then they draw conclusions based upon that. So that's an observational study. We're going to look at populations and samples, a set of all elements about which we wish to draw conclusions. So an example might be this business statistics class. Each person in the class would be an element, and then say there's 40 students, then that is 40 is the population. If we wanted to know all of the information about all 40 students in the class, that would be called a census. We would conduct a census on the whole population. So census is an examination of the population of measurements. If for some reason the class was 1 million people large and we wanted to glean information about the class, but we just didn't have the resources to cover all 1 million people, we would grab a sample, which is just a subset of the elements of a population. And we've all heard sample before. And then we have observations, which is the measurement of the variable of interest for each and every population unit, or just any population unit, really. You can take an observation on a sample or an observation on the population. And then there's descriptive statistics versus statistical inference. And so descriptive statistics is going to refer to running statistics on the population as a whole, and then just knowing the information about the population. Whereas statistical inference is going to be running statistics on a sample of that population and then making conclusions about the population based on the sample. So we kind of just mentioned, like, what if the population is just too large and we don't have the resources to run testing or gather data on every single element of the population? So we would this is what you'll find that we do in this course is we'll take a sample, we'll conduct tests and figure out and obtain data, conduct tests and whatnot on the sample, and then we draw conclusions about the population based upon that sample. Here's what we'll do. We will look at the cell phone case. I'll read that off, and then we'll look into identifying some of the characteristics of the cell phone case in our worksheet. Okay. So rising costs rising cell phone costs have forced companies having large numbers of cellular users to hire services to manage their cellular and other wireless resources. These cellular management services use sophisticated software and mathematical models to choose cost-efficient cell phone plans for their clients. One such firm, Mind Wireless of Austin, Texas, specializes in automated wireless cost management. According to Kevin Whitehurst, co-founder of Mind Wireless, cell phone carriers count on overage, which is using more minutes than one's plan allows, and on underage, which is using fewer minutes than those already paid for, to deliver almost half of their revenues. As a result, a company's typical cost of cell phone use can be excessive, 18 cents per minute or more. However, Mr. Whitehurst explains that by using Mind Wireless automated cost management to select calling plans, this cost can be reduced to 12 cents per minute or less. In this case, we consider a bank that wishes to decide whether to hire a cellular management service to choose its employees' calling plans. While the bank has over 10,000 employees on many different types of calling plans, a cellular management service suggests that by studying the calling patterns of cellular users on 500 minute per month plans, the bank can accurately assess whether its cell phone costs can be substantially reduced. The bank has 2,136 employees on a variety of 500 minute plans with different basic monthly rates, different overage charges, and different additional costs for long distance and roaming, etc. It would be extremely time consuming to analyze in detail the cell phone bills of all 2,136 employees. Therefore, the bank will estimate its cellular costs for the 500 minute plans by analyzing last month's cell phone bills for a random sample of 100 employees of these plans. This is on page 9 of your book. When the random sample of 100 employees is chosen, the number of cellular minutes used by each sampled employee during the month, the employee's cellular usage, is found and recorded. The 100 cellular usage figures given in table 1.4, that's pictured above. Looking at this table, we can see that there is substantial overage and underage. Many employees used far more than 500 minutes, while many others failed to use all the 500 minutes allowed by their plan. In Chapter 3, we will use these 100 usage figures to estimate the bank's cellular cost and decide whether the bank should hire a cellular management service. So we have this data set here. We can see that there are plenty of people that have went over 500. There's plenty of people that are considerably under 500, and so that's our data set. So now we're going to go over to our review sheet or our exercise sheet, and we're going to answer some of these questions. So what is the population of this? 2136. There was 2136 elements. Did we conduct a census? No. We didn't conduct a census because we thought that it would be too expensive. So rather than doing a census, we did a sample. Yes, we did a sample. And in the sample, how many observations did we have? We had n equal 100. Descriptive statistics. No, because that would have been about a population. So no, because no. Pop. And statistical inference, that's what we would eventually do. So we'll just say yes. So the statistical inference piece is, this is how we would go about analyzing the data. We're looking at a sample. We're going to draw conclusions based upon that sample about the population. Okay, head back over to the PowerPoint and to the next page. And then this is the last part of our first chapter, and this is looking at ratio, interval, ordinal, and nominative scales of measurement. And nominative is just a qualitative variable for which there's no meaningful order or rank of the categories. So examples would be gender, car color, eye color. Um, so when we have all that data down there, like it's basically saying that like there's no gender, like one gender is no better than the other. No car color is better than the other. No eye color is better than the other. It's like it's just is what it is. It's just different, right? So like there's no ranking of red to blue to green of car color. It just is a quality about the data. Okay. Ordinal is also a qualitative variable for which there is meaningful ranking order. So if somebody asked you to answer a survey on teaching effectiveness, how effective was this teacher 1 through 10 or A through F, like A through A, B, C, D, F has a ranking, has an order. That would be ordinal. 1 to 100, grade them on that scale. That has an order. So that would be ordinal. Order, ordinal. There you go. Then interval, all the characteristics of ordinal, plus there is an arbitrary zero. So 0 is assigned, it's non-physical and not meaningful. The best example of interval as a scale of measurement is temperature. So 0, like 0 degrees Fahrenheit, obviously means cold, but it doesn't mean no heat, right? So 0 is not like an absolute 0, which coincidentally in temperature there is an absolute 0. But so we're looking at 0 degrees Fahrenheit. That 0 is just a point on the scale. It's not the absence of temperature. Okay, so that's what makes that. That's what makes that interval. And then equally, you can't compare interval values by ratio. So, like, say we're talking about 20 degrees and 40 degrees. 40 degrees is 20 degrees more. Did I say that right? 40 degrees is 20 degrees more than 20 degrees, right? But 40 degrees is not twice as hot as 20 degrees is. That's what signifies interval. Or, well, that's what's eventually going to signify ratio. So ratio you can compare by the ratios of them, but interval you cannot. So we move on to ratio. All the characteristics of interval plus 0 actually does mean nothing. And similarly to what I just explained, it has the characteristics of interval in that $30 is $20 more than $10, but $30 is also 3 times as many as $10 is. And 0 does, in fact, 0 isn't just a point on the money scale. It does, in fact, mean no money or $0. Okay, some examples of this in business: earnings, profit, loss, age, distance, height, weight, whatever. So now we're going to refer back to the worksheet. And we're just going to talk through whether these are nominal, ordinal, interval, or ratio. And personal computing operating system, no ranking order of these. I mean, if you wanted to take it, if you could establish like oldest to newest, then you can, I guess, potentially make an ordinal, but that's not what we're doing. We're just saying these are the categories. So nominal. Motion picture classifications, G, PG, PG-13, R, NC-17, and X. These do have a ranking order, right? This is the ranking order for how kid-friendly they are. So this would be ordinal. Level of education: elementary school, middle school, high school, college. These do have an order to them. They're progressing in age, difficulty, sort of thing. So that's ordinal. Rankings of top 10 college football teams. This one's tricky. So this would be interval, except that there's no insignificant 0 there. So it's just ordinal, even though they are numbers. So ordinal can be numbers, but if there's no 0, and they can't be compared like a ratio, then they're going to be ordinal. Exchange on which a stock is traded. There's no order to that, so it's just nominal. Zip code. No order to that. There's like no one zip code is better than another, so nominal. And temperature. We actually just use this as an example. We know that that is interval. And salary of a teacher in the thousands, and that's going to be our ratio. Okay, guys, I would like to thank you for tuning in for Chapter 1 lecture notes, and I will also have the review up and Chapter 2 up as well. All right, thanks so much. Take care. Bye.